Let's look at problems that need to be modeled first before they can be solved. And example 1 says 20 more than the square of a number is the same as 9 times the number. Find the number solved by factoring. First thing we're going to do is we're going to let x represent the number that we're looking for. And now let's take a closer look here. The word is, or the words is the same as, imply equal, an equal sign. So we have something on the left or of the equal sign and something on the right side of the equal sign. On the left, we have 20 more than the square of a number. That means you're going to take the number x and square it and then add 20 to it. So x squared plus 20 would appear on the left side. On the right side, we have 9 times the number. The number is x, so 9 times x would be written like this. So this is the equation that models the problem. Okay, before we can solve by factoring, we have to make one side equal to 0. So I'm going to subtract 9x from both sides to give me x squared minus 9x plus 20 equal to 0. Now I'm going to factor. There's nothing that I can factor out. That's common. And next, I notice that this is a simple trinomial. So I'm going to factor it using product and sum. The product is 20, the sum's negative 9, and then the two numbers that satisfy that product and sum will be negative 5 and negative 4. The factored form will then be x minus 5 times x minus 4 equal to 0. And then if I want to find what x is equal to, I said each of the factors equal to 0 and solve for x. So x would have to be 5 in order for the first bracket to be 0, and x will have to equal to 4 in order for the second bracket to be equal to 0. So those are my two solutions to this problem. There's two answers. Now for word problems, especially the ones you're trying to model, it's always a good idea just to check and verify your answers. So we do that by checking to see if the left side equals the right side. So I'm going to check if 5 satisfies the equation. So I see that on the left side of my equation I have x squared plus 20. And on the right side of my equation I have 9x. And if x is equal to 5, I would have 5 squared plus 20, which would give me 45. And if x is equal to 5 on the right side, I have 9 times 5, which will also equal to 45. So since the left side is equal to the right side, I know that 5 satisfies this equation and it's the correct solution. You can do the same thing with 4. You can sub in 4, and 4 squared is 16 when you add 20 to get 36. And 9 times 4 would give you 36. The left side equals the right side, so that's the correct solution. Okay, let's look at some more word problems. Here's another one. This is a little bit more complicated. It says the sum of the squares of two consecutive integers is 113. Find the integers and solve by factoring. So again, we're going to let x represent the first integer. Now, consecutive integers means they follow each other on the number line. So 1 and 2 are consecutive integers, and negative 3 and negative 2 are consecutive integers. Okay, so that there's one unit separating consecutive integers. So if my first integer is x, the second integer that follows it on the number line, or the consecutive integer, would be 1 more than x. Okay? And it says that the sum of their squares, that means you square the numbers of x and x plus 1, and then you add them together because the word sum implies addition. So we have x squared, and we're going to add to that x plus 1 squared. So I took the numbers, I squared them, added them together. Okay? And then we have the word is again, which means equals. 113. So this is the equation that models the problem, and now we have to expand everything and put in the form x squared plus bx plus c equal to 0 before we can factor. So remember that x plus 1 squared really means that you're multiplying x plus 1 by itself, and that you're going to have to expand it by multiplying each term in the first bracket by each term in the second bracket. So when I multiply x through, I get x squared plus x, and then when I multiply 1 through, I get x plus 1. Okay, and then I can subtract 113 from the left side and the right side to make the right side 0, and then I can combine my like terms. So I have x squared and x squared, which combine to give me 2x squared. I have x and x, which combine to give me 2x, and then I have 1 and negative 113, which combine to give me negative 112. And all of that will equal to 0. Now I'm ready to start factoring. I notice that here I can factor out a common factor of 2. So that I end up with 2 times x squared plus x minus 56. The trinomial that remains in the bracket here is a simple trinomial, so I'm going to factor it using the product and sum. So product is negative 56 and the sum is positive 1. So the two numbers that satisfy that product and sum are going to be 8 and negative 7. So the factored form would be x plus 8 times x minus 7. And then the roots would be negative 8 and positive 7. So negative 8 plus 8 would make this bracket equal to 0. 7 minus 7 would make the second bracket equal to 0. Now what did x represent? X represented only the first integer. So the first integer could be negative 8 or it could be 7. Now what about the second consecutive integer? Well, if the first integer is x and it is negative 8, the second integer will be x plus 1. It would be 1 more than negative 8. It would be negative 7. If the first integer is 7, the second integer that follows it on the number line will be 8. So there's actually two answers for this problem. So therefore, the integers could be negative 8 and negative 7, or 7 and 8. Both of these will satisfy the equation. Okay. So for example, if I take negative 8 here and I square it, I get 64. And if I take negative 7 and square it, I would get 49. And if I combine 64 and 49, I get 113. The same thing happens when I use the positive values. Okay, let's look at one more example here. It says the dimensions of a rectangular garden were 6 meters by 8 meters. Each dimension was increased by the same amount. The garden then had an area of 99 meters squared. Find the dimensions of the new garden, solved by factoring. Well, if we knew by what dimension or by what amount each dimension was increased by, then we would be able to determine the dimensions of the new garden. So in this case, we're going to let x represent the amount of increase. And then I'm going to write the equation. To help us with the equation, you can always draw a sketch. Here's the rectangle. Okay, its original dimensions were 8 and 6 meters. Okay, and then it says that these were increased by some amount represented by x. So I'm increasing 8 by x. How do I write that? I write it as 8 plus x. Same with the width. I'm increasing it by an amount of x, so I write it as 6 plus x. Okay. And since we know the area of this new garden is 99, we can use these expressions for the length and width to come up with the equation, because area is length times width. So my length is 8 plus x, and my width is 6 plus x, and that will equal to an area of 99. Now I'm going to expand the two brackets. First I'm going to multiply the 8 through, and that will give me 48 plus 8x. Then I'm going to multiply the 6 through to give me 6x and x squared. Next I'm going to subtract 99 from both sides to make the right side equal to 0. And then I'm going to collect my like terms. So first I have 1x squared term, then I have 8x and 6x that I can combine to give me 14x, and then I have 48 minus 99, which gives me an answer of 51. That's going to be negative. Okay. Next step is to factor this. So I have a product of negative 51 and a sum of 14. So I can determine the two numbers to be, when I think about it, is going to be 17 and negative 3. And then the factored form would be x plus 17, x minus 3. Setting each factor equal to 0, I get an answer of negative 17 and positive 3. Now only one of these answers makes sense in the context of the problem because x represents the amount of increase. We're not going to increase by a negative amount. Okay, so the amount of increase had to be 3. So to find the new dimensions, I add 3 to the original dimensions of 8 plus 6. If I add 3 to 8, I get 11, and if I add 3 to 6, I get 9. So the dimensions of the new garden are 9 by 11. And don't forget to include the units.